Hello, ladies and gentlemen, boys and girls. My name is OctoMan, and in this tutorial, I want to talk about 2D grid-based movement. So, since I got a request about how that is going to work and what are the differences, or actually what can be taken or can be done over here, this is what I'm gonna talk about today. So what I want to do is first I want to have some character in the 2D space. So what we can do is we just take one of our characters and bring this into the scene. What we need to check is, or what we actually need to take care of, is how big our actual character is going to be. So, and you probably noticed that I already used this character over here, so no worries about that at all. So, what I want to make sure is that when I move in kind of a grid space or grid way, then I want to make sure that this one is able to move from one grid cell basically to another grid cell. So, but as you can see, depending on the size of our character itself, like of the sprite, and the scale and all the other content, the grid can be different. And based on this input, there are multiple things we can take a look into, or we should. So in that case, as an example, hey, you roll, thanks a lot for tuning in. So in that case, when our character should move like one step to the left or one step to the side, right or up or down or even diagonal, there is no issue with that at all. Because we just need to understand how far our character needs to walk. Let's assume we're gonna duplicate now our character and bring this like to the right, for example. By the way, we can also do activate grid-based movement. So, but let's assume I'm gonna put the character 2 to the left and 2 to the up. You're gonna see that this diagonal is going to be like laid out later on inside of a square-based grid, no matter where it is. But I can take this number, like the 2 at the position 2, 2, as an input indicator. Also, there are going to be those other ones where we can basically say something like, okay, we're gonna move 2 up, but 0 in the y-axis in this case, which actually is going to be like, well, 2 up in y, of course, but x is going to stay 0. So this would be basically the size or the length of the grid movement overall, if I wanted to be it this way. You can also make it smaller, bigger, it doesn't really matter at all. What we want to do is when we want to implement or we want to make use of this particular number, the number 2, and implement this. And it doesn't really matter where we are in the world. And that was the request actually. So what I wanted to do is I want to just explain how this movement is going to work and what different possibilities we are going to have. I don't go over an animation in this case. I just want to keep it short today. So I just gonna create a movement script over here and just, you know, apply this to my little graphic over here, to my walk jump guy. So once that compiler is done running, I'm gonna implement this so that the movement is going to be directly onto my character. If you don't want to work like that, you can also make a child object or a parent object and put all your graphics onto it. Once again, it depends on what you want to actually make sure or what you want to work with. For people who are actually wondering what the problem is with that lines in the center, these are just the shaded or the wireframe of my 2D object over here. I'm gonna disable my, or just let my firewall go through. So I just deactivate it twice, and once it's done, I'm gonna be able to put in like anything for my particular, you know, script over here as well. Once again, you can make use of MonoDevelop, Visual Studio, whatever you're pleasing like. In Update, we just need to declare what are going to be our actual inputs. So what are the keys we want to make use of? In that case, we can easily or simply go and, you know, do the navigation directly for our character itself. So, and later on, we just add whatever the distance is, like the actual grid size or whatever we define to be the actual grid size, to the actual movement, and then we do the lerping, you know, between those 2 points. So what we want to do is we first want to check for input. In this case, an if statement basically is the easiest one over here. So if we're gonna do some input dot get key. So when we hold down the key, get key is going to be the one we're gonna actually fire. And now we wanna actually request, for example, key code A for the left side. You can always go and comment things out to keep stuff simple and easy and organized and understandable for you. So if we are choosing the left direction, then we want to do the actual input, and we can now take whatever we want. We can take the the raw input, like from whatever the, an axis is going to be, or we're gonna do just that with keyboard inputs like A, D, W, S, probably also Q, E, Y, and C, depending on how far you want to go with all these inputs. Now we just need to define what we want to do whenever that is going to happen. Also, we want to implement a boolean called isMoving. So we want to make sure that we are not moving, so we, like whenever we do this input, we are not moving, that we are actually switching the actual functionality of all this content. So whenever we are in this particular part over here, we're gonna be able to put in an AND operator. Hi Scaleman, thanks a lot for tuning in. So what we now can do to check is if we are actually moving or not. If we are not moving, like we're gonna actually deactivate that, or say with an exclamation mark in front, we're gonna set it to be the negative one. So if we are not isMovement, or movement is actually not correct. If not moving, let me name it like that. So if we are not moving and we are putting or holding down the key, then we're gonna put some, something into this operation. We're gonna set isMoving basically to be equal to true again, I guess. So whenever we are done with that, we're gonna be able to drive our character based on whatever the grid size is. So the grid size can now defined by different values. Example is going to be a vector. Let's make this vector public so we understand what are the problems with these numbers and how can we implement or increment the amount to, or the direction basically where we want to move to. For example, we can also just define an x and a y coordinate, for example, with a float or with an integer, as we are using full numbers, and so on. There are hundreds of possibilities in this case based on specific numbers we can set. For example, let's just create a vector. So the vector can be, or basically is going to be an input by a positive, let's say x, and a positive y. So in that case we can make use of a 2D vector. So public vector2. So this just contains two variables, x and y. We can give it a name. Let's say a grid size. I can't type today, as usual. And then we can later on in the inspector, we can define that. But we can also say we're gonna set it or give it a preset. Basically, it doesn't matter. Let's keep it as is so we get an idea behind the actual grid size. So we're gonna have later on a grid size x and a grid size y. Once again, you can also use two floats to separate that and probably make it a bit easier to understand if there are any issues with that. So what we want to do is, if we are not moving, of course we want to make it so that we are able to move. So we set isMoving is equal to true. At the same time, whenever we are basically done with that input and we're gonna move from one point, like from basically a start point and an end point, we want to of course calculate that, but also we want to check if we are moving. So if isMoving is true, then we want to get a start point, for in this case also a vector we can make use of, since we are using 2D, a vector2, or if we are using 3D we can use a vector3. So in that case I'm gonna make a new vector2, gonna name this one start point. So the start point is actually the transformed position, so the position where our character is going to be. So in that case, it's just taking the x and the y coordinate from the transform, since the transform component usually gives us back a vector3, as you can see over here, but is still working on a vector2. If you want to once again make use of a vector3, you can use that as well. Also, we want to now declare another vector2, in this case an endpoint, so where we want to go to. And we want to set this to whatever it is. And whenever we are done with that, we want to lerp to a specific position. So we're going to be able to lerp between 2 points. So in that case, we're going to take or create a new vector 2. And now we're gonna take the x and the y coordinate and then add whatever we wanted to be basically whatever the input is going to be. For example, for an a, we're gonna need to define the actual, size of the vector and add it to the current vector, so basically to the current transform dot position. So in that case, we can once again have multiple possibilities. We can, for example, say we're gonna calculate that transform dot position, so our current position, and add a new vector 2 to it with whatever the input is. So in that case, we can also once again declare that. We can also store our next point or our endpoint. Probably it's easier to do that. So we can store the information somewhere. Like, for example, whenever we already do the input, and then we just say we're gonna move to that particular already calculated input over here. Once again, there are hundreds of possibilities to do that. Let's do this that way. So we're gonna call the endpoint, or we store the endpoint over here. And whenever we do the press, we want to define whatever the input is, for example, not whenever we are just moving, but whenever, let's say, we are doing input. Since A is going to be the left position, we're going to calculate this by whatever our vector or our grid size X is going to be, but Y gonna stay the same. So in that case, we're going to have whatever, in this case, grid size dot X is going to be, as well as a 0 on the Y axis, because we only want to move to the left. What you now can see, we're going to have a problem with that transform position, because this, once again, is a vector 3. This is a vector 2. What we can do is we can actually change that also to be a vector 3, but we need to implement the z-axis here as well, so we can declare this just as a 0 as well. So we only move over grid x size, but when we are going left, we're going to need to negate the grid size x over here. I hope you understand this one. So basically that is where we're gonna go to. When we now wanna, since we now have that stored, that endpoint has been stored, we wanna make sure that we are going, downwards into the code line. Then we're gonna have, okay, if is moving is going to be true, because we are setting this one over here to be true, we wanna now lerp from the start point to our stored endpoint. In that case, we can, for example, do something like transform.position is equal to vector3.lerp. We can, I believe, also make use of a vector2.lerp, if there is any one. There we go. So we're gonna be able to lerp from two vector 2s. So in this case, once again, we take the endpoint over here. That's going to be our endpoint in this case. So we start to lerp from our start point to our endpoint, and what we're going to need to define is some kind of a speed variable. How fast do we want to do this? So in that case, we're going to, for example, do something like a float over here. We can also use an integer. And we declare something like a speed variable, for example, is equal to, I don't know, 5f. You can make this higher and slower or lower later on. In that case, we're going to put in the speed variable, multiply that. Well, that's what we are usually doing by time.delta time. Don't forget to end the line with a semicolon. So now we have another problem. We don't know when do we want to make sure that we are actually putting is moving back to be false. So in this case, let's assume we now don't have is moving over here. Now we activate is moving, and we set the endpoint, because of the key input A, to the negative grid size X. What's going to happen in the next turn, or in this same iteration, is, okay, we get into here, we basically create the start point, and then we want to do the transform. But when we are doing, or what probably can happen right now is, whenever we are, or while we are moving along, that we are not able to finish this lerping over here. Why? Because we anyhow need to deactivate is moving again. So what we now can do is we can basically take all this if movement or is moving stuff and put this as an example into a coroutine. And the coroutine is going to take care of the movement. Let's take a look into this. We're going to create an IE numerator. because it's easier to handle and we don't have like hundreds of if else, if else, if else, you know, all that stuff. So in that case, we're gonna just say move. So the coroutine is going to take care of all the actual, you know, inputs. And what we're gonna say is while we are already moving, we just break out of that. So we say if is moving. So meanwhile we are already moving. And by the way, we're gonna change that in a sec here as well. So if we are moving already, we say yield break. We want to break out of this I numerator because we only want to have or want this to happen once. So what we now want to do is at the very end, whenever the coroutine is done, the movement is completely done, we want to reset is moving to be equal to false. Also, whenever we are like going above or behind this part, so we not break out over here, we want to set is moving to be true over here. Of course, typos. So instead of having this now on to the input, we're gonna have this in the coroutine. We're gonna deactivate this like so. I'm gonna be able to once again keep on actually recalculating the actual endpoint, but we only do this when we are not moving. Otherwise, we would keep on recreating the endpoint. So we always need to make sure that we are not moving at this point whenever we do so. So whenever we now go into this coroutine, we're gonna take like all this content over here. I'm gonna hit Ctrl X and cut it out. And what we now want to declare is the start point over here. We're gonna lerp to the position. Meanwhile, we are inside. We're gonna hopefully keep on lerping. And whenever we are basically done, well, we're gonna take a look into this in a sec, and we want to make sure that we are leaving the actual I numerator again. And then whenever the next input comes, because we are holding down, for example, a key, or we just push it once, basically doesn't matter at this point, we want to make sure that the movement works correct. Let me comment this one out over here, and let's go into start coroutine. And what we want to start is the move coroutine, of course. And now, since I only have the key code A, I'm gonna save my movement script and go back to Unity and see if the console drives me any input issues or something like that. So the movement is over here. I don't have any grid size set yet, so as you can see, I can now put in any vector size, for example, a 2, 2. Why 2, 2? Because that is going to be the size now from one grid position to another grid position I want to go to. When I now press play and I hit my A key once, I'm gonna move to the left. It seems that it does not complete the movement as I wanted that to be. So as you can see, it did the actual movement, and also I bet when I hold down A, I'm gonna keep on moving to the left because the coroutine always activates and deactivates itself. So what we now need to do is we need to wait until we are basically onto our endpoint. So in that case, we can now, for example, put this into some kind of an external functionality where we are checking if we already hit the position. In that case, we can take a bool in over here. So move to point or move to position, whatever. And we're gonna put in basically nothing. What we want to say is we want to measure if we are already moving to this particular point. I wonder if we can actually put this into another while loop. So while the transform to position lerping is not finished, or transform to position is not equal basically the endpoint, we probably are able to keep that running. Let's try that. While sometimes while loop, by the way, can be picky, so just take care of that. So while transform.position is not equal, and even that cannot or might not work correct, well, is not equal to endpoint, well, that is not a good one, I guess. And also not possible because, once again, this is a vector 3, this is a vector 2. Let's do it with the bool and try that out. So what we want to actually return is the actual goal over here, or the end point, or yeah, the end point. So what we want to do is we want to now make sure that we are moving or doing the lerp. Meanwhile, we are waiting until our transformed position is going to happen. So I'm gonna take this, gonna cut it out, bring this over here, and put this into a pair of parentheses. Well, at the first place. Start point, as you can see, is not available over here, but we're gonna make it so that we're gonna put vector 2 start over here. So, or start point. I'm gonna put this there. Now what we want to make sure is, meanwhile, our transform position is not equal. Let's see. Oh, we cannot do this. That's actually not a good one. We're gonna need to find another way to do this. Vector 2 and vector 3 cannot be taken in this case. Okay, so that is actually not a cool one. So we need to take a vector 3 in this case. So endpoint needs to be a vector 3. Which is not a bad one actually. So we don't get any issues over here, as you can see. So now, meanwhile, we are not actually returning that the transformed position is going to be at the endpoint over here, and we're going to implement that over there. We're going to do the axial movement. So what we now take is we're going to take a while loop once again. So while, and now we're going to take move to point, and we're going to put the actual calculated start point into this. We want to yield return null. So we say yield return null over here. So once we are done with that, then we go and pass by. Let's see if that works now. So I'm gonna press play, hit my A key, and I just tipped it once. So it doesn't keep on going to our actual calculated endpoint, which is bad. Instead of using lerp, we might go and take a move towards a point. Maybe that's a bit more consistent or a bit more precise instead of lerping using move towards. Nope, that stops kind of instantly. I believe I need to do transformed position to endpoint over here, so we're gonna actually take the current position and not the start point position, otherwise it would probably just reset. So let's test this out over here. I'm sorry for the wait, so sometimes you know, I need to think about what I'm going to do. And there we go. So now I can basically move 2 points to the left, so 2 grid points from this, 1, 2, and now we basically can do the opposite here as well. So in that case, we just take the complete left side over here. We're gonna copy this content and gonna do the D key over here. I don't once again go over the actual animation of that sprite because it's just simply by rotating it. We already talked about it. So basically I'm gonna increment the X size over here and to the right side by hitting the D key. The same is going to happen now for the other sides. So basically when you're going up, you're gonna take the W key over here for moving upwards, and in this case X is going to stay 0, and we're gonna take now the grid size dot Y in the positive direction, and we're gonna be able to do the same for the downwards direction as well. So we're gonna take the S key over here for moving downwards, and saying we're gonna take the negative grid size Y. Don't forget to save and let the compiler run. And let's test it out. So I'm gonna move up, hopefully. There we go. I'm gonna move down, go left, go right. And so now we have a bit grid-based movement. And the cool thing about it is I can hold down the key, the left key, the right key, whichever key, and it's going to always move inside the grid. So it always rounds it up basically. If you want to put in like a diagonal movement, you can do this as well. For example, with the Q key. So I'm gonna show you that for here as well. So basically the diagonal top left is going to be now the Q one. So on top left. And in this case, we're gonna take the negative grid size y, or no, in this case x, and the negative grid size y over here, so we can also do negative, or in this case diagonal movement to the top left corner. Over here, I'm gonna show that in a sec. Once the compiler is done running, I'm gonna press play. And now I'm able to move down, and also I should now hit the Q key. Oh, I got it downwards, so going to do the positive grid size y over here and negative grid size x. Yep, there we go. So now we can do this. We can move left, right, up, down, as well as diagonal by, as you can see, the same grid size. If you have like smaller characters or bigger characters, you just need to actually change the y, no, not the y, but the grid size itself. For example, you can now take any grid size you want, for example 1 and 1. You can also take 1 and 20. So in that case, we now just put the grid size over here, and now we just do smaller steps from here to here. Of course, the speed is going to stay the same, but looks a bit different. And I can also hold down the key, left and right, up and down, everything now on a grid. Now we can also watch the Q key, as you can see, goes completely diagonal over here. That's everything I wanted to cover in this little tutorial. I still hope you guys enjoyed this one, and I hope to see you in one of the next tutorials over here. Thanks a lot for tuning in, and have a nice day. Bye bye.